No, you don't have to. You could just draw a like open plain circle would be fine. You don't have to fill it all in if you want. Okay? We are starting notes. No, not yet. That'll be next chapter. We are just looking at a compass. All right, we're going to talk about, because we've been talking about degrees, and degrees are related to how you read a compass, because a compass is divided up into degrees, and that's related to the reference angles triangles we've been working on. So you're going to see the connection between all of those things, hopefully, today. A compass is divided up north, south, east, west. Okay, and then it's further subdivided. Each of those corners, our quadrants, are divided in half and then in half again. And so these are assigned degree values. We start with north being assigned 0. Okay, that is 0 degree position, and 90 degree position is east. So if that's true, what is northeast? Very good. Northeast is 45. All right, so again, halfway between north and east. So halfway between north and east is northeast, and then halfway between those, you'll have north-northeast and east-northeast. Those are divided in half again. So the north-northeast is 22.5 degrees, and then halfway between the 45 and the 90, do another 22.5, so that's 67.5 degrees. So all of the positions on a compass have a degree assigned to it. So you should be able to split things in half and work backwards to figure out the different assignments for the degrees. So of course, another 90 would put 180 down here on south. Another 90 degrees would put 270 over on the west. And then you get back to 360 again, because when you read a compass, you go clockwise. Okay, you always go in a clockwise manner when you read the compass. This picture is in your textbook on page 320. It's either 325 or 326. So if you want to write that in your notes, like see page 325, or 326. I can't remember exactly which page it's on. So I guess what I'm wondering from you is, what would south, southeast be in terms of its degree measurement? South, southeast. Anybody want to try that? You can, yeah, for sure, use a calculator. I don't care. What do you think? Double check. How would you figure it out? I mean, what's the mental math on that? Where is south, southeast? Do you find it? Do you see it? Okay, it's less than 180, so it's smaller. How much smaller than 180? 22.5 degrees. So what does that give you? 157.5 degrees. And that comes from 180 minus 22.5. Okay, what about southwest? Okay, southwest. Okay, how do you figure that out? Okay, go ahead, Danny, I heard you kind of mentally doing it. How did you figure that out?
I added 45 from 180.
Okay, he added 45 to 180. Okay, because we're looking at this mark right there. So that's 45 degrees beyond 180. And so that gives you 225. Are you getting basic idea? Any questions about that? So what we need to do now is work on turning bearing into reference triangles. Okay, so that's what we're going to practice for the next couple examples, and then finally we're going to end up with one big doozy of an example. Okay? All right, so let's practice making bearing into reference triangles. All right, so create a reference triangle for bearing 38 degrees. So we're going to superimpose this onto an axis. So you're going to go ahead and make your axis. You'll mark off 32 degrees. So since our degrees for compasses start with 0 at the top, then 32, and always go 0 and then clockwise off to the right. So we'll measure out approximately 32 degrees. But now I need to create 38 degrees. Now we need to create the reference triangle from that. So I'm just going to switch colors here so we can draw the reference triangle. So the reference triangle goes up that bearing line, but has to connect to what axis? Has to connect to the x-axis. And so when you create the bearing rectangle, what actually goes inside that theta corner of your bearing triangle? How much? 52. Oops, I don't want to make it that fat. Okay, so yeah, 52. Oops, come on. Okay, because the bearing of 38 combines with the 52 below to make a total of 90 degrees. So just because you have a bearing of 32 doesn't mean the reference angle is going to have, triangle is going to have 32. You have to do the subtraction with 180 degrees to figure that out. All right, we're going to do that for the next several examples. I'm going to give you just the bearing, and then you create the reference triangle. All right, so what would it look like if bearing was 110? What would the reference triangle be for 110? All right, so think about where 110 would be. What quadrant does that drop you into? Remember, if you start at 0 up at the top, where does 110 drop you into? Quadrant 3 would be beyond 180. So I'm actually in quadrant 4. So 110 is about like right there. Okay, that's where your bearing is. But when I create my reference triangle for that particular bearing, it's going to look like this. Is the 110 actually in the reference triangle anywhere? The answer is no. Okay, because the 110 measurement included the 90 degrees of the first quadrant. How many more degrees are there in the fourth quadrant? If I had 90, and then how many extra? 20. Okay, so I had 90 here, and then I have 20 more here. That's a total of 110. So my reference triangle is going to be based on the number 20 as my theta angle, not the number 110. So again, bearing doesn't usually end up as part of your reference triangle. It helps you to design the reference triangle, but you got to use the 90 degrees to help you figure out what the actual bearing is. Okay, let's try another one. Let's do, what if it would be something like this? What about 217? All right, what quadrant is 217 in? Okay, it's in quadrant 3. Now it doesn't have to be perfect, okay, but somewhere in quadrant 3. Yeah?
What are the quadrants?
Oh, 1, 2, 3, 4. Okay, so 217 is going to be in quadrant 3. Because we know where 225 is. Danny helped us out with that. So 217, you're not going to be far off. We'll estimate 217. Okay, now, 217 isn't actually part of my reference triangle. Because when I design my reference triangle, there's the line for the hypotenuse, but where am I connecting it to? I have to connect it to what axis? The x-axis. So remember, let's zoom in on this and take a look. 217, that's 90. Oops, I forget to change it back. Okay, that's 90 from quadrant 1. That's another 90 from quadrant 4. So 90 and 90. How much more beyond that am I into the quadrant 3? I've got 90 and I've got 90. I need to get to 217. So how much more?
217 minus
which is 37. Okay, so that's 37 more. So add them all up, 90 and 90 and 37, that's 217. That's where I need to be for my bearing, because you always go clockwise. But what's actually in the reference triangle?
90.
Yeah, which is 53. Okay, so actually in the bearing triangle is 53. So the biggest or most common mistake I will see, kudos to Greg, who's not here, is that students will just see 217 and they'll just make 217 part of their bearing triangle, or maybe they'll even do the 37 and they'll put 37 in their reference triangle when it's not really 37 at all. It's 53, which is the rest of it to get to the quadrant. Let's do one more just for practice on this. Okay. How about how about 308? All right, so you should be able to picture where 308 is. Okay, 308 ends you up in quadrant 2. We know where 270 is, that would be here. We know where 360 is, that would be up top. So 308 is going to be somewhere, not quite perfectly in the middle, but we'll say it's about right there. So when I create my reference triangle for 308, my reference triangle looks like this. Oh, I don't like that. Okay, there's my reference triangle. So when I'm labeling my bearing for that reference triangle, I need to get up to 308. So I start in quadrant 1, there's 90. Then I use the next quadrant, quadrant 4, there's 90 more. And then 90 more. I haven't gotten to 308 yet. 90 and 90, 90, that's 270. How much more to get me to 308? Okay, 38. And that's actually in the reference triangle. So the 38 degrees is what would be part of my reference triangle. Yeah.
So like the one that we did last time, like 217, the 37 would only be out if it's in quadrant 3.
37 is out because it's in quadrant 3.
So
Because the reference triangle has to connect up to the x-axis. And 37 doesn't touch the x-axis, does it?
No.
37 touches the y-axis. So which is why, for my reference, I need to go beyond the 37 and get the rest of it, which was 53 more, to be part of my reference triangle. Okay, and that happens in quadrant 3 like that. Okay, other questions? Okay, so what does that have to do with the SOHCAHTOA trig that we were doing before? All right, so let's say a drone. Okay, a drone flies at a bearing of 121 for 15 minutes at 12 miles per hour. Okay, how would you design a reference triangle for that particular situation? So you've got the bearing for the drone, you've got the time that the drone is flying, and you have the speed the drone is flying at. So let's see if we can first get our bearing and then get our reference triangle and label some of the sides on that reference triangle. So here's our 121. Okay, what quadrant? Quadrant 4. Okay, because 90 degrees would be here, and then 121 would need to be some degrees beyond that. So I'm going to have, okay, how many degrees beyond 90? 31 degrees. Okay, that's a total of 121 together. So just always double check your total to make sure you're up to 121 altogether. Okay, so my reference triangle for this drone would look like this. Now, is the drone flying the path of the A side, the B side, or the C side? Is the drone flying? Does it fly like this? Bzz, bzz, that how the drone flew? Or does the drone just fly in a straight line along the hypotenuse?
Goes up and
No, the drone is just flying in a straight line. Drones, they just get up and they fly. They don't have to like worry about corners or anything like that. They don't follow street signs. The drone is just going this way. Okay, so let's zoom in on this a minute. So I've got my drone in here is flying this direction. There's the direction of the drone. 15 minutes at 12 miles an hour. How far do you get? How far does the drone get? So 12 miles an hour means in 1 hour, how far would he get? 12 miles. That's what 12 miles per hour means. Okay, well, he didn't go a full hour. What if he'd only gone a half an hour? Okay, if we'd only gone a half an hour, how far would he have gotten? 6 miles. But he didn't go even a half an hour. He only went 15 minutes. So a quarter of an hour. So my drone went 3 miles. And that is the value of your hypotenuse. We do not know the B side. We do not know the A side. But we can figure them out using SOHCAHTOA. So if I needed SOHCAHTOA, I would set up a SOHCAHTOA. I'd actually set up a sine for A and cosine for B. Gonna make it? So we would have sine of 31. That would be the A over the number 3, and I could cross multiply because my hypotenuse was 3. And I'd have cos 31 is going to be adjacent over hypotenuse, which is going to be B over 3, and I'd cross multiply to figure those out. So when I cross multiply, A turns out to be 3 sine 31 degrees. And when I cross multiply for the B, B turns out to be 3 cos 31 degrees. All right, that was the first time we tried something like that. So let's try something. Let's try another one.
Would you simplify that further? Or would you multiply that 3?
Yeah, if they wanted like you to round to a certain number of decimal places. Yeah, I'm not going to grab my calculator and do that at this point. Okay, let's try another one. Yep. Okay. Okay, a plane has a heading 261 degrees. The plane flies for 3.5 hours at 425 miles per hour. So create a reference triangle for that situation. So you want to start with the bearing. You want to get the bearing right, and then you can create your reference triangle from that. So a plane has a heading 261. It's pretty close to 270, but what quadrant will that be in? Quadrant 3, all right, 261. So 261 will be heading like that. All right, we know that that's 270, so here's 261. But I want to assign the 90 and the 90 and stuff to get these in the right values. So we're going to assign 90 degrees to quadrant 1. We'll assign another 90 degrees to quadrant 4. So we're working our way. How much more do I need to get me up to 261? I've got 90. How much more do I need? Okay, I need 81 more degrees. Is 81 part of my reference triangle? No. So how much is actually, better zoom way in on that, how much is actually in the reference triangle? Just 9, that tiny little 9. All right, so my reference triangle is actually then going to be here to here to here. And I can use the speed of the plane and how long the plane has been in the air to figure out the hypotenuse of the path of the plane. So the plane is flying along the path of the hypotenuse, and it's been going at 425 miles an hour for 3.5 hours. So how far has it gotten? 425 miles per hour for 300 or 3.5 hours. How far? Go ahead.
1,487.5.
Yep, I concur. Okay, how'd you get that?
Well, I just divided 425 by 2, and then I just multiplied 425. And I multiplied 125 times 3, and then just added the half.
Okay, all right, so he knew that in the first hour he'd went 325, in the second hour he'd go another, excuse me, 425, and then the second hour another 425, and then the third hour another 425, so that's 3 hours of the 425, and then adding half of it more. Okay, you could just do 425 times 3.5. That would also work. All right, gives you the same thing, yes.
Is there an equation for this?
Yes, it's distance equals rate times time. Remember that from like middle school, probably?
I remember the, like those equations. I don't know.
Distance equals rate times time. So the rate is 425 and the time is 3.5, and you just multiply together. So Hayden was just using logic, but yeah, if you want a formula, you're going to multiply 1,487.5 miles. And then what that will allow me to do now that I have hypotenuse, now I can figure out what the A and the B are for each one. So let me label so we can clean this up a little bit. So my B side and my A side, and you can use sine and cosine again. So A is again the sine of 9 degrees, because that's what's in the reference triangle, is A over 1,487.5. And then the cosine of 9 degrees would be B over 1,487.5. Cross multiply, get your answer. I'm not going to do that right now. I'm going to save that for the next problem. Any questions so far? Here's our 2 that we've done. Okay, just setting up the reference triangle. Okay, now we're going to do one problem with a boat, and we're going to actually like do it the whole way out. You okay, Quentin? You need to come closer?
Did you just zoom in on the bottom?
Yep. Okay, we'll do one, and we're going to do it from start to finish all the way, and we're going to get the decimal values. Okay, so example. Okay, a boat heads out for 2 hours at a heading of a bearing of 53 degrees and a speed of 35 knots. Knots is the measurement on water for speed. It stands for nautical miles per hour, but then rather than just saying nautical miles per hour every time, people just say knots. Okay, but it means nautical, which is on water, miles per hour. Okay. It then adjusts its heading. All right, so maybe it gets an SOS call, or maybe it finds out that there's going to be a storm coming and it needs to turn directions, or it is going to run into a little spit of sand, or a sandbar is in the way, so it has to adjust. So it adjusts its bearing to 143 and sails for 3 hours more. How far away is it from the origin, from its origin? How far is it now from its origin? All right, so we're going to do this whole problem start to finish. I'm going to suggest if your boat or ship or plane or helicopter or drone or whatever makes a turn, do 2 separate triangles. Okay? Literally do 2 separate triangles, do the problem separately, and then put them together at the end. Don't try and do it all at the same time. It's going to make it way too messy and confusing. So let's just start with the first heading of 53 degrees. So here's my boat heading out at 53 degrees. 53 is about like that. I'll put 53. Okay, starting at 0. Creating my reference triangle for this boat. Okay. So we're coming out here. Here's my reference triangle. So what measurement actually goes in the reference triangle? Can we quickly figure that out? 37. Good. So that's the rest of the 90 degrees. So we've got 37 degrees in our reference triangle. Okay, what about the hypotenuse of the path of this boat if it's been going for 2 hours at 35 knots? Say it again? 70, right. So 70, that's 2 hours times the 70 miles per hour. All right, so let's actually get our calculators out and let's figure out what the A and the B are for this. A here, that relationship is going to be based on sine. So that would be sine of 37 degrees is A over 70. And we'll cross multiply so that A would be 70 times sine 37. If somebody could figure that out for me, that would save me a little bit of time. That'd be great. And then B, that'll be the cosine because it's adjacent. So cosine would be B over 70. If somebody else could figure that out, I'll call for it in just a minute. When we cross multiply, we'll have that. Okay, so I'm ready for sine. Does somebody have that for me? 42.127, okay. Miles. Okay, so, oops, lost it. And then somebody for the B side? 904 miles. Okay, great. So that is the first leg of the journey. Oh, sorry, I'll leave that zoomed in for those of you who are trying to copy that. Okay, now we want to work on the second leg, and then we're going to put the two legs together. All right, so the second leg of the journey changes the heading to 143. So now the heading is going to be like this. 143 is like that. When I want to label 143, I got to go 90 in my first quadrant, and then I need to go additional 53 more to be in my second quadrant. That's a total of 143. And I'll design my reference triangle. And this time the hypotenuse is my boat has gone 3 more hours at the same speed at 35 miles an hour. So if it's just going 35 miles an hour, if I'm not changing the speed and it's going 1 hour more than it went before, how far has it gone? 105. Okay. And then we can find our A and our B from that. So B would be here, A would be here, same thing. Using sine to find A, so sine of 53 degrees, that would be A over 105. So cross multiply, I'll have somebody work on that for me. Okay, sine 53. And then B would be using cosine. So the cosine would be, or excuse me, B is going to be 105 cosine 53. All right, and I'll take those values if somebody has it. Does somebody have A? 857 miles, okay, and then I need B from somebody.
60.
Say it again, Danny. 60?
63.191.
Okay, miles. All right, those are the two legs of the journey separately from each other. So now I want to put it together. So what I'm going to do is draw it like this. Here's my first reference triangle, looked like that. At this green dot, I need to connect it to the second reference triangle at the origin of the second reference triangle. And the second reference triangle looked like this. Okay, that's the green dot, or at that green dot. So I've connected the two reference triangles together. And I'm going to recommend that you label the sides of your reference triangle, or of these different triangles. So we had 83.857 here. We had 63.191. We had 55.904. And shoot, what was the last one? 42.127. 42.127. I don't need to worry about the hypotenuses, just this. My question is, to finally answer the whole problem, is how far away is it now from where it started? In other words, from this point to that point, how far away is it now? So you need one final triangle connecting here to here to here. Okay? One final triangle. So put it all together. Of the red triangle I've drawn, how long is that longest side? Can you put it together and figure it out? How much? Okay, 55,904 plus 63,191. I don't know, what does that come out to be, ladies and gentlemen? Okay, I'm going to write it down. 119 point what? 095 miles. Okay. How about the shorter side? Okay. How about the shorter side? How do I figure that out? Subtract 42. So I'm going to take the larger number, subtract the smaller number, 83.857, the longer one, subtract the shorter one. Okay, what does that come out to be? 41.73 even? Right on the nose? Okay. So if I know those two sides, Pythagorean theorem, which is back from Monday, Pythagorean theorem to help us figure out the final missing piece. Okay, so then we'll go back to a squared plus b squared equals c squared. So that would be 119.095 squared plus 47.73 squared equals c squared. And so then it's up to you to type those in and then figure out the decimal and then figure out the square root. Did you do it already, Annika?
No, I did it with 41 because I couldn't read your one.
Oh, okay. Okay, all right. 120, what was it before the square root? Can you tell me that? 15,925, right on the nose? Okay, and then we square root all of that, right? All right, so then that turns out to be 120 point miles. Was there anything after the 9? All right. Most of your problems are going to be one triangle problems. It's like, whew, phew. Okay, but there will be one or two that are the two triangle problems where you got to do them separately and then connect them together.